Imagine inheriting a huge cloud environment like virtual machines, virtual network interfaces, all running perfectly. But there is no Terraform code in place. How do you turn that existing infrastructure into something that you can manage cleanly in Terraform without blowing everything up, right? So let's walk you through how Terraform used to handle this, why it was a pain, and why it just got way better. Hi everyone, my name is Contrigger and welcome to my channel, where we dive deep into cloud, DevOps, and AI topics that keep you ahead of the curve. If you like actionable, real-world content you can apply today, you're in the right place. So let's dive into today's topic. Back in the day, and even today for many, importing an existing cloud resource into Terraform meant manually using Terraform Import CLI command, right? As we see in this slide, in order to import your cloud environment, you should do Terraform. You should use this Terraform CLI. It goes as Terraform import, and your reference of your resource in your Terraform configuration, following up with your resource ID, so your Terraform will be importing that remote cloud resource into your Terraform configuration, right? This looks very easy, but the real OGs who has gone through this pain knows the actual hitches, gotchas along the way. Even though this was working, I had a lot of problem using this CLI, especially in a very big scale environment. So when it comes to the problems, every import had to be done manually with the CLI command. Forget one little character in the resource address and Terraform would either fail or import incorrectly, as we see here. I had this problem a couple times where I needed to be very careful about it, right? This is the first problem. Manual and error prone is everywhere. Going forward, there is no documentation in the code. Whatever needs to happen, it's either goes through locally with the CLI in your terminal, or depends on your CI/CD process or other processes, you go there. But there's not really a good state that keeps track of who has imported which resource, right? And the other thing is, the other problem is non-reusability. Sometimes you cannot really import your resources through your CI/CD because in enterprise levels, there is no usage of local Terraform, right? Everything needs to go through some CI/CD process with approvals and workflows, and you won't have that much of an access and exposure into your environment, so you won't have that flexibility to play around with imported. So for me, in a couple of my projects, we were not even able to import resources because of the CI/CD process. We didn't have any access to the state, or we didn't have any access to the code base in the CI/CD process. We were just able to deploy and manage things. So that was one of the biggest problems we had. So right now, this is gone, hopefully, with the new feature. And the last problem that I want to mention is the not scalable, right? So as you know, Terraform Import CLI works one by one. You need to do manual one by one importing. And in a large enterprises, if you have 500 resources to import, that's a nightmare. That's a lot of manual work to do, which I've gone through. And I'm so happy to share this new feature that's going to solve this problem, right? If we understood the problems with the current or the old legacy Terraform import CLI command, let's jump into the new feature and what is it like, how it looks like. Here we are with the import documentation of Terraform HashiCorp. So first thing first, we need to realize is there's a note saying this Terraform import code block feature supports starting from Terraform version 1.5.0. So make sure you're at least using this version or the later ones. I think the latest version is right now is 1.1.11, right? And we do have an experimental note saying while we do not expect to make backwards incompatible changes to syntax, the generate config flag and how Terraform process imports during the plan stage and generates configuration map change in the feature releases. So make sure to keep that in mind. And here you can see there's the description from HashiCorp that I already explained. Like unlike the Terraform import command, there's a configuration-driven import using import blocks, is predictable, works with CI/CD pipelines, which was one of the biggest problems that we were facing. And the syntax given as an example here is, this is how the import code block looks like, right? We have import open brackets to, which means to which Terraform configuration that we're importing into, and the ID of the cloud resource that we want to import, right? And this is the Terraform configuration for the resource itself, and it explains here. The import ID argument can be a literal string of your resource imports ID or an expression that evaluates to a string such as var.instance ID. So you you don't necessarily need to put string IDs here. You can basically do some magics taken from variables or local variables, especially if you want to use for each loops, right? So here we do have the local bucket list in AWS, and here we do have the AWS S3 bucket resource, which is creating multiple buckets with for each loop. But if you want to import all of these buckets, here you can see it's importing through for each loop, taking a look at the local bucket string list here, mapping here actually, and it basically says, hey, go to this resource, for each key import the buckets with the each values ID, right? So you can basically use for each loops for bigger scale environments if you have repetitive resources. Or the other process that you can use to expand the import across multiple module instances, i.e. if you have different, for example, if your buckets are with different configurations, you can basically get them into local variables with some of their specific attributes or the values, and with the import code block through for each loops, you can basically import them. And here about the plan and apply, as how it works is basically you add this import code block into your Terraform configuration, you run your Terraform plan, it shows you what it's gonna do. If you're satisfied with the output, what you can do is basically you can run Terraform apply to do the import. Then afterwards you can either leave this Terraform import code block into the code, which is not going to be do anything. The import code blocks only works for once. So if you do Terraform apply for once, like the other runs will not pick that import no matter what happens, right? But you can remove after applying as well if you want to keep your code base clean. Okay, and we have we have other examples in the HashiCorp documentation, which I will be linking this into the description. So if you understood how the import code block works, let's do some demo. Let's demonstrate a couple scenarios that we can use this to have some hands-on experience. All right, I'll see you guys in the demo. Okay, so here we're in our Azure portal today. I'll be doing the demonstration through Azure Resources, but this applies to any hyperscale that Terraform supports, right? So in my resource group, I have a bunch of resources. Some of them are not in my Terraform configuration, i.e. we're going to try importing resource group, virtual machines, virtual machine components like network interface cards, public IPs, virtual networks, subnets, and we have storage accounts that we're going to try this for each loop to import with, right? So in my Visual Studio, what I'm going to do is I do have my Terraform code configured here beforehand, but in terms of if we need any help, we're gonna leverage GitHub Copilot for some automation. All right. So first, what I want to do here is I do have this Azure Terraform Resources folder, which is basically pure resources without any modularization. Okay, so in the main TF, you can see these are direct resource usages that I want to show you guys. So here we do have the resource group, we do have network, subnet, public IP, a network security group, network interface, association for the network security group, and our Windows virtual machine, right? So first, what I want to do here is I want to go into this folder, and then what I want to do here is I want to tell my Copilot, hey, I want to import my resources into this code base in Azure. Actually, we can do folder, right? And generate import blocks for each resource to import from portal, right? So let's see how the GitHub Copilot agent will work with this. So what we're planning to have after this is basically it's reading this main TF file, which we expect to have import code blocks generated here. If it needs IDs, we're gonna retrieve the IDs from portal and put them into the blocks. Okay, so it's still doing the updates, so I'll just keep them up here. What it has done is basically it put import code blocks for each resource group above the resource configuration. Here you can see import to this resource with this ID, then did the same thing for network, subnet, public IP, security group, interface, network interface, and all others. So what I am planning to do is I want to go and see if we do have that virtual machine here, or do we need to use something else? So looks like we don't have it. So what I'm going to do is I'm going to use other virtual machine. So what I want to do here is basically I want to use this one, right? So here, this is my resource group. I'm going to take this, put it here, right? And this is going to be my virtual machine, which I want to put it, this is VNet. So I want to put my virtual machine up here. And if we go back, this is my public IP, which needs to be my one. Okay, public IP goes here. Our NSG goes here. And our network interface card is network security interface card is here, which goes here. Then disk, we let it stay like that. So what I'm gonna do is I'm going to replace this one with our RG name. Okay, I'm gonna replace those, and we have some problems here. I wonder what's the problem. Okay, let's use Copilot to fix this. Let's see. Okay, so I fixed the syntax issues, and got all of the import code blocks here properly. Right now we do have import code block for each of the resources here. What we're gonna do is I want to run Terraform plan here to see the output of the plan, how it reacts, right? So what we're expecting is to have imports. There you go. So as you can see, we do have 6 to import, 7 to add, 6 to destroy. The reason for this is our Terraform code configuration doesn't 100% match with the existing resources, which most of the attributes forces replacement, right? So you don't want to replace the existing attributes. And normally what you need to do is you basically need to check the plan and sync the attribute values from your plan output into your code base. So we're going to utilize GitHub Copilot saying, hey, run tf plan and check the output and match my code with the existing resource values to avoid redeployments. Right. So what I'm going to do, what I'm planning to have is Copilot Agent will run the Terraform plan for me, and it's going to inspect the output that we have seen in the terminal. Then it's going to modify our Terraform code base based on this output. So right now it can see several discrepancies between our code and the existing environment, right? So what it's going to do, hopefully, what I want it to do is to update our code base. So now, as you can see, it's updating the code base without me doing anything, right? Matching the values. Perfect. I keep the changes. And what I'm going to do, I'm not going to do anything. It's asking to run the Terraform plan, which I'll give the permission to, right? Now it's running it, and let's see what we're going to get. Perfect, right? So we don't have any destroyers. We have 6 to import, 1 to add, 1 to change. So I wonder what is the add here. For some reason, I cannot go to side. Okay, the network security group will be created, it says. Do we have... Okay, we do have the networks. Oh, we don't have the import code block for the network security group. So what I'm going to do is... Oh, okay, it basically gave me the code block here, which we need to clarify, right? So if I want to go to network security groups here, which is going to be my Windows, right? I want to get this one, and I wanted to remove it here. So now what I'm gonna do is I'm gonna run it one more time, and hopefully we're gonna have 6 imports only. Okay, 1 to destroy. Okay, network security group, resource group name is this. Network security group must be replaced. We need to update our network security group here. Then we should be fine. Perfect. So we have 17 port, nothing to destroy. which what we want, right? If we run Terraform apply from this point, no existing resources will be redeployed or changed. So we're going to have the resource configurations in our Terraform code base in a matter of minutes. So this is how you do Terraform resource import with these code blocks. You have your resources here, right? So now let's jump into the module import. Okay, so if we want to mimic some real world examples, i.e. in your enterprise or company, based on the best practices, it's good to have modules and modularized deployments, right? So when we talk about the modules, it's a concept of reusable code base that you can do deployments upon without doing duplication code, right? We do have source modules here created for the environment. It's basic modules, as you can see. Main up variable TFs are there. And if I jump into my main.tf, which has the modularized deployments here, what I'm going to see is first, we do have some local variables for the storage accounts. This is for import for each loop, right? So I'm going to show you guys later on. But if I jump into the module deployments here, I can see I do have modules that are getting the code from source modules that we have, right? Everything is pretty basic. We have hard-coded values for the demo purposes. So right now I do have my import code blocks already prepared for this, right? We're not going to go through each of them, but the difference between the resource import and import into the resource and the import into the module is just the two reference, right? Destination reference. So in your destination, instead of giving the resource Azure resource destination name, you need to give your module dot module name and follows with the resource reference name here, which we have done for all of them. Okay, so jumping into the storage accounts to showcase how to do import with for each loop is what I have done here. I do say for each in local variables called storage account map, which we have it here. Right here we have the convert list to a map key to by storage account for easier reference. So we say for storage account in local storage accounts, take the name and map it to the storage account, which is basically here we have storage accounts local variable, which has the name for each storage account with the IDs, right? The reason we're doing this, we want to loop through these storage accounts and import them into the new code base. So here I go to that local storage account map, and for the to destination, what I do is go to the storage account module, our storage account reference name, and for each storage account, import it there, right? In the storage account, each key, it's going to import it separately, and IDs will be each storage account's ID, which is in this case, it's gonna go to here, which is the key. It's gonna take the key from the name, then it's going to take a look at the each storage account's ID to import. Okay, this is how you can import with for each loop. So if I want to go here, say Terraform plan, right, in my root for the module import, as you can see, we have 9 to import, 8 to add, 6 to destroy. So this is not what we expect because our Terraform code is not synchronized with the existing resources. So what I want to do is GitHub Copilot Agent. I'm saying, hey, I want to do import into my modules, run TF plan in my root for modules, and take a look at the output and sync my code with the existing resource configs, right? So instead of me just taking a look at each of the differences, updating my code, I want my GitHub Copilot to handle it for me. This is a huge time saver, effort saver from my experience, because this was one of the biggest parts that we had to deal with during import process, right? Import getting the plan is fine, but updating the huge code is a pain in this process. So it's basically says there are several key issues that need to be addressed, and let's see what it's going to do. So my Copilot works a bit slow because of my internet itself. It's not about Copilot, right? The reaction time really depends on your internet speed. So just to keep that in mind, sometimes I do have some problems with these. So right now it's updating my code base to sync up, right? Perfect. So it basically changed my storage account names, right? Turns out that they were different in the portal, which I keep the changes. Now it's taking a look at the variables.tf for the modules. You can easily see which file the agent is working on here. So I'm basically accepting whatever comes, but make sure you always test the changes that comes from AI agents. Right now it says it's updating the main module of the networking. So this is pretty good because it's not only the deployable module update. If there are any changes needs to be updated in your module, maybe during writing your own source modules, you might forgot some capabilities, features, attributes. Your agent can pick it up basically as it does here and update your source modules, right? And still working on a lot of modules. So once it's done, we'll be back. Okay, so I work with the agent. It fixed a lot. Right now, the final output is 10 to import, 1 to change, 0 to destroy, 0 to add. So it was a lot of import, a lot of changes and adds because of the modules and this and that. I told my agent, hey, I don't want to have any changes and adds. Make sure to only have imports that is synchronized with my existing resources, which has done the work. Right now it's asking if we should apply. So let's apply this and import these resources in Terraform code block. Yes, go ahead with apply, right? So I tell it to do apply itself. What's going to happen is it's going to ask to run the apply command here, hopefully soon. So here I give the permission. It runs the Terraform apply in my terminal, which is going to import the resources into our modules. Right now, it's doing the magic, asking for confirmation. As you know, you can skip it by doing --auto-approve. Right now, importing our resources and done. That's how fast you can import a whole environment with the Terraform new code blocks into your new configurations like that, right? That's an amazing feature. As someone who has gone through that CLI pain and spent days and days for importing, this is a huge improvement. That's how you do it. So the old import command got the job done, but not without a pain. The import code block is the feature clean, scalable, and part of your infrastructure code forever if you would like it. Use it and your future self and your team will thank you. If you like this video, smash the like button, subscribe for more cloud, DevOps, and AI gems, and share it with your team. Until next time.